In this video, we'll learn how to apply a uniformly varying load in Ansys APDL, both using and without using code. For simplicity, I've considered a cantilever beam which has only this UVL as the applied load. Let's consider a square cross-section of 250 mm side and material properties of E equals to 200 gigapascals and Poisson's ratio equals to 0.3. Now the pre-processing step, which includes defining the element type, material properties, cross-section and meshing the geometry, it's same for both ways of defining UVL. So let's complete the pre-processing step quickly. Go to Mechanical APDL and first of all change the job name to uniformly varying load or anything you like. Okay, I'll also change the title to uniformly varying load. Okay, this title will appear in each of my screenshots. Now go to preferences and select structural. Now in the pre-processing step, first of all let's define the element type, add edit delete, add and select beam 188. Okay, it's a 3D beam with 2 nodes. And now go to options and set the element behavior to quadratic form. Okay, close. Now to specify the material, go to material properties, material models, structural, linear, elastic, isotropic and input the values of E, which is 200 gigapascals, that is 2 times 10 to the power 5 Newton per millimeter square, and Poisson's ratio is 0.3. Click OK, close this. Then to specify the cross section, go to sections, beam, common sections, and since this is a square cross section, apply input 250 and 250 for both B and H. We can click preview to observe the cross section geometry. Click OK. Now to create the geometry, go to modeling, create key points in active CS. Here we have to input our 2 key points. Key point 1 is 0, 0 and key point 2 is 1200, 0. To input key point 1 we can just click apply, and to input key point 2 we have to type 1200 and click OK. So we have our 2 key points. And go to lines in active coordinate to create the lines. Select near key point 1 and click near key point 2. So our geometry is done. Now before meshing, we need to specify the size of the mesh. For that, go to size controls, click manual size and click lines and all lines. That means that we are using same mesh size for all lines. Actually we have only one line, so it doesn't make any difference. Here we can either specify the element edge length or the number of element divisions. For simplicity, I'm only using 3 divisions so that we'll only have to do 3 calculations, but it might be coarser for our requirement. Okay, after that go to mesh and click lines and select pcol. So our meshing is done. To visualize the mesh elements, we can go to plot controls, numbering and enable element numbering. Okay, so we have 3 mesh elements. Now let's apply the loads. Go to define load, apply structural and apply displacement loads on key points. Since key point 1 is fixed load, provide all degree of freedom a constant value of 0. Click OK. Now we have to apply the UVL. Let's first apply the UVL using graphical user interface and not using code. For that we need to do certain calculations. We only have 3 mesh elements, so we need to do only 3 calculations. The finer the mesh, more calculations are required. So this method is not that efficient. What we have to do is divide the complete UVL into separate UVLs like this for each mesh element. Then by linear interpolation we can calculate the value of UVL at each nodes like this. Now we can apply pressure on each element easily. So let's go back to APDL and select pressure and select on beams. So in first beam the load key is 2 for vertical loads, and for the first beam value at I is 0 and value at j is 2. Click apply. For the second beam value at I is 2 and value at j is 4. Click apply. And for the final beam or third beam, the value at I is 4 and value at j is 6. Click OK and go to plot and click elements. So this is how we apply uniformly varying loads using graphical user interface. Now we can solve this problem and do the post-processing. Now let's go to the code part. What the code does is exactly the same calculations as we did with the linear interpolation. This is a small piece of code which is used to apply UVL for our beam. It's a simple do loop. The k is the iteration variable of the loop, which takes the values from 1 to 3 with an increment of 1. Since we have 3 elements, so k takes values of 1, 2 and 3. For the first iteration, that means for the first element, k equals to 1. Here 2 is the load key representing vertical load. Press means we are applying pressure load, and these two are values at I node and j node respectively. For the first element, k is equal to 1. Pressure at I node is 1 minus 1 times something 0, consistent. For the j node, it's 1 minus 0 times 2 and 2, consistent. In the same manner, it calculates the values of pressure at I and j nodes of each element. So however fine the mesh is, there's no problem. So let's copy this code and go back to APDL. So I have copied the code, and here in APDL I have already recreated the geometry and did all pre-processing steps except the load. Now paste the code in the command line like this and click enter and go to plot and plot elements. So these are the two ways of applying UVL in Ansys APDL, and the code method is very much easy and efficient. Now we can solve this problem by going to solution and clicking solve, current ls, OK. So the solution is done. We can also go to general post processing, plot results, deformed shape, and let's see deformed as well as undeformed edge. Okay. And in a similar way we can continue the post processing from here.